The number line. Is the one that we learn in grade school the only one there is? And if there are others, what do they look like? And how many of them are there? In fact, what is a number line? Well, let's define it somehow. So the key points are a number line has to be based on some sort of rules. It has to organize numbers spatially in some way, and it's got to be useful somehow. So now let's draw that number line that we all know how to draw from grade school. But this time, let's take our time and see if we can figure out what the rules are that we're actually using to create that number line. So let's draw that number line. We'll put a big arrow on one side to show that the numbers get bigger in that direction and go on forever, and the little arrow on the other side to show that they go on forever in that direction too. Now we're going to show what the basic rule is for this number line. Our standard number line uses addition, so we're going to put a plus here. Now we make a starting point. But what do we label it with? We all know we label it with 0, but why 0? This is an important thing to recognize when you're creating your number line. We start with 0 because 0 is the additive identity. Anything plus 0 gives us back what we started with. We make another mark now showing what our standard distance is. This gives us a sense of our scale, or how close or far away we're zoomed into the number line. We also label it with the next number. Then we just keep on going. As we move to the right, we add to the next number. And of course, as we learned in school, the number lines just don't go one direction, they go both directions. So if we move to the left, they get smaller and we subtract. Let's make a key observation here. Now that we've defined the operator on the number line, the start point, and the length to the successor, the property of distance emerges. On this number line, equal length intervals have equal differences between their endpoints. One way to learn new math is to take what you already know and then modify it and see what happens. So let's take the number line that we just made and change one of the rules. Let's still use the same straight number line in direction of increasing numbers that we did on the last number line. But this time, let's make our number line based on a different operator, multiplication. So now we mark the starting point again. But we can't label it as 0 like we did before, because since we're multiplying, if we multiply by 0, every other number on the number line will also be 0. So what do we mark it as? So on our additive number line, we chose 0 because that was the number that had the property that when we added it to any other number, we'd get that number back, the additive identity. So since we're multiplying on this number line, what number has that same property for multiplication? Yep. We want to use 1. 1's the multiplicative identity. Okay, so next we define the standard distance unit again. And we label it with what? We've got to define a standard multiplication unit, but what is that? Turns out that this is an arbitrary choice. We can use any number except for 0 and 1. Whatever we choose is called our base for the number line. I will call it 1, 0. Since most people read that as 10, we can use 10 too. So now we rinse and repeat. Keep multiplying by the base for each step to the right. And just like on the last number line, when we're going right, we're multiplying in this case. So going to the left will be division. So we divide by the base each step to the left. So now our number line is done except for a few details. This number line also has a concept of distance as well, though now it's based on multiplication, so the interpretation is a little different. Equal distances on the number line have equal ratios between their endpoints. In other words, if I divide the right endpoint by the left endpoint, I'll get a ratio, a number, which tells us how many times bigger the right endpoint is compared to the left. Also, it seems like we're missing a whole bunch of natural numbers on this number line. Where do we put all the numbers between 1 and 10? Well, if we look at the natural numbers in each interval, we start to see a pattern. As we move to the right, we cram more and more natural numbers into each interval. So that means that the natural numbers are being compressed together as they go to the right. So as we go to the left, they also start to expand. Now with that observation in mind, we can place the remaining natural numbers between 1 and 10 in that first interval, compressing them to the right like this. Lastly, we can utilize our concept of a standard interval as multiplication by the base in order to fill in the natural numbers in the other intervals, like this. And with that, we've created a new number line. This number line is called the logarithmic number line. So in summary, what we did in this video is we took a piece of math that we knew about, the additive number line, really looked at it closely, figured out what the rules were for it, and then we changed one of those rules and logically followed it to its conclusion, a new number line. I hope you liked this video, and we'll come back when we build on it a little bit more in the future. Thanks for watching. Hope to see you again.